So hi everyone, today we are going to discuss about two questions on chemical process principle. The first question is adapted from January 2013, question 4. Now the question is, an evaporator is fed continuously with 25 tons per hour of a solution that contains 10% sodium chloride, NaCl, 10% sodium hydroxide, NaOH, and 80% of water, H2O. So during the evaporation process, water is boiled away from solution, and sodium chloride precipitates out as crystals, which are settled and removed from filtration from the remaining thick liquid. The thick liquid leaving the evaporator contains 50% sodium hydroxide, 1% sodium chloride, and 49% of water. So the question here wants us to calculate the amount of water evaporated, the amount of salt produced in kilogram per hour, the amount of thick liquid in kilogram per hour. Now, after we have read the question, what we're gonna do is we have to draw out the block diagram. Now, from the question we can know that there is one input and three output. So one input and three output. So the first input, the input is 25 tons per hour, as mentioned here. And then the molar composition is 0.1 NaCl, 0.1 NaOH, and 0.8 H2O, as mentioned here. Now, we have three output here. The first output is water, so water, H2O. And then the second output is sodium chloride, so NaCl. And the third output is thick liquid. Now, with the question given is the molar composition of thick liquid, so 0.5 NaOH, 0.01 NaCl, and 0.49 H2O. So after we have drawn out the block diagram, what we're gonna do is we have to figure out the DOF analysis. So from the block diagram given that we draw, we can know that there's three variables here, N1, N2, and N3. So NV equals to 3, N1, N2, and N3. Now, we have three species balance here, NaCl balance, NaOH balance, and H2O balance. So three species balance. So our DOF equals to 0. Now, after we have known the DOF equals to 0, means the question can be solved. So the first things we're gonna do is we have to change the 25 tons per hour to kilomole per hour. So we can do like this, 25 tons per hour times 1000 kg, because 1 tons equals to 1000 kg, and then 1 kilomole equals to 25.25 kg, because 24.25 is the molecular weight of the composition here. So 0.1 times 58.5, 0.1 times 40, and 0.8 times 18 equals to 24.25. So after we have get the molar flow rate, we can write here 1030.93 kilomole per hour. Okay, now after we have gotten the molar flow rate, we can do the NaOH balance. So input equals to output, 1030.93 times 0.1 equals N1 times 0.5 NaOH. So we get our N1 equals to 206.19. So we can N1 equals 206.19. So we know N1 and we have gotten our input in kilomole per hour. Now what we're gonna do is we have to find the amount of water evaporated. So N3 here. So how are we going to find N3? We can do the H2O balance. See. Now, to find amount of water evaporated, we can do H2O balance. So input is 1030.0.8, then times N3, then plus N1 times 0.49. So we get our entry is 723.71. So our entry is 723.71. So we have solved the first. So the second one is amount of salt produced in kilogram per hour. So amount of salt produced in kilogram per hour. What we can do is we do the NaCl balance. So the input is here, 1030.93 times 0.1 plus N2 plus N1 times 0.01. So yeah, and then we get our N2. N2 is equal to 101.03. So now we have gotten all the unknown here. But now the question 1 in kilogram per hour. So we have to change our answer in kilogram per hour. So the question 1 is in kilogram per hour. So 101.03 kilomole per hour, we times the molecular weight of NaCl. So 23 plus 35.5. So we get the answer in kilogram per hour, 5,910.26 kilogram per hour. So to find the amount of thick liquid in kilogram per hour, as we can see here, we have found the thick liquid, but in kilomole per hour. So what we're going to do is we have to change the flow rate in kilomole per hours to kilogram per hours. So the same thing, we have to find the molecular weight of the thick liquid, and then we got 6,063.02 kilogram per hour. So the question now is solved. The first thing we get, the amount of water evaporated is 723.71 kilomole per hour, and then we got the salt produced in kilogram per hour as mentioned in question. So 5,910.26 kilogram per hour. So the thick liquid is also 6,063.02 kilogram per hour. So the question now is solved. Now let's proceed to the next example. The next example is adapted from January 2014, question 5. The question is, in the vapor phase hydration of ethylene to ethanol, diethyl ether is obtained as byproduct. So here's the equation. And then the question here is, a feed mixture consisting of 60% ethylene, 3% inerts, and 37% of water is sent to the reactor. The product analysis: 53.89% of ethylene, 14.37% of ethanol, 1.8% of ether, 26.35% of water, and 3.59% of inerts. So the question wants us to calculate the conversion of ethylene, the yield of ethanol, and the yield of ether based on ethylene. So now, as usual, after we have read the question, what we're gonna do is we have to draw out the block diagram. So here's the equation and then the block diagram. The question is quite simple. The question has only one input and one output. So the input, we have 60% of ethylene, so 0.6 C2H4, and then 3% inerts, so 0.03 inerts, and then 37% of water, so 0.37 H2O. So for the output, we have 53.89 ethylene, and then 14.37 ethanol, yeah, and then 1.8% of ether, yes, correct. So 26.35 of water, so 0.2, yes, correct. And then we have 3.59% of inerts, yes. So the block diagram is now complete. So the question does not give us the output, the flow rate of the output. So we put the as one unknown, and then for the input we can set the basis as 100 moles per hour to make our life easier. So after we have drawn out the block diagram, we can now solve the question. Now, the first question is conversion of ethylene. So conversion of ethylene, C2H4, then C2H4 here. So conversion of ethylene, the formula is like this. Initial mole minus final mole over initial mole. So 100 times 0.6 minus N1 times 0.5389. So how do we find N1? We can find N1 by using the inert balance. So 100 times 0.03 equals to N1 times 0.0359. So we get our N1 equals to 83.5655. So N1 is 83.5655 mole per hour. So now we get our N1. Then we can solve the question. So we substitute in the N1 and then we get the conversion of ethylene equals to 0.2494. Yes, correct. And then the next question is yield of ethanol. So for the yield of ethanol, we can calculate it by using the formula number of moles of product that actually form and the maximum possible number of moles of product. So number of moles of product actually form, you can refer to here. Here is the number of moles that actually form. So N1 times 0.1437 divided by the maximum possible number of moles of product is here because of this equation. So N1 times 0.1437 divided by 100 times 0.6. So we get our 0.2. So this is the yield of ethanol. So the last question is yield of ether based on ethylene. So ether is this one, and then based on ethylene. So N1 times 0.018 divided by 100 times 0.6. So we get our answer 0.025. Now the question is solved. The conversion of ethylene equals to 0.2494. The yield of ethanol equals to 0.2. And the yield of ether based on ethylene is 0.025. Here is 0.2494. So the question is solved. So thank you everyone for listening, and I hope you guys understand what I'm trying to explain. So thank you very much and bye.